Okay, today we're going to do something super exciting. We're going to learn the derivatives of the trig functions. So I've got here sine of x graphed, and we're going to investigate the derivatives of the trig functions graphically. And that'll be a little bit easier to teach you through a video. So here's sine of x. Hopefully you recognize that as sine of x. So we're going to think about, well, what would the derivative of this function look like? So I'm going to just sketch a different graph here next to it. Sometimes we put the new graphs on top of each other. It'll be easier this time to put it on next to each other. So now if I'm looking at this sine of x graph here, okay, and I'm going to say, well, let's talk about what the derivative would look like. Well, I can see there's definitely things happening to the derivative here and here, right? At these 2 points, I mean, sine of x has got a maximum there, right? So I know that the derivative is going to be changing from positive to negative at x equals pi over 2. And the derivative, and sine of x has a minimum right here at 3 pi over 2. So I know that the derivative is going to be changing from negative to positive at 3 pi over 2. Which also means, because this function is nice and smooth, the derivative is not only going to change from positive to negative, it's going to actually pass through 0. So I'm going to go over here and put pi over 2 and 3 pi over 2. And I say, well, I know it's positive to negative, so I'm thinking, okay, well, it's going to be like something like that there, and then negative to positive, something like that there, right? And then if you think about, if we were to continue this on, there's going to be another positive to negative over here, which means that the derivative is going to have to change direction. In order to come back and cross over here, the derivative is going to have to change direction. So now we've got this, and then I've got to go down and get back up somehow. So maybe it looks something like that. And if you remember your trig, you're probably saying to yourself, hey, that looks an awful lot like the cosine function. And you would be right, because the derivative of sine of x is cosine of x. And you notice the positive to negative, negative to positive, got a max, got a min. Okay? So there you go. I mean, I think that right there is probably convincing enough for us. Let's just talk about some other pieces, though. This derivative, we said right here, is decreasing, right? And when the derivative is decreasing, so the derivative is decreasing from here to here, correct? The function is concave down. So the function's concave down there. Sine of x is concave down. And then the derivative is increasing right here. The function sine of x is concave up. So I think this is pretty convincing that the derivative of sine of x is cosine of x. In fact, if we were to compute this limit, which we all know is the definition of the derivative of sine of x, the answer that we would get algebraically is cosine of x, okay? We're not going to compute this here. Maybe we'll go through this when you guys come back someday. But at least I want you to see that, the answer to this limit would be cosine of x, okay? So we can pretty confidently say here that the derivative of sine of x is cosine of x. So what if I were thinking the other way? What if I were interested in, well, what's the derivative of cosine of x? Like, what if I were to go from cosine, okay, and I want to take the derivative of that? Well, you would see here's cosine of x, right? Let's do it in different colors so this pops. Here's cosine of x, right? Cosine's got a max there, a min there, and a max there. And hopefully you know that's 0. Hopefully you know this is pi, and this is 2 pi. So cosine's derivative, okay, cosine's derivative is going to go, well, and let's just do this too, make it a little better. What happened to my pink marker? Oh, here it is. Cosine, let's do this just to make it a little better. Cosine's derivative, if I'm looking for the derivative of cosine now, cosine's derivative is going to go from positive to negative at 0. From positive to negative at 0. And cosine's derivative, in fact, we can even positive to negative. And then cosine's derivative at pi is going to go from negative to positive. And cosine's derivative at 2 pi, we automatically know it's positive to negative because this is a periodic function and it repeats. Oops, should have done that in green. Okay. So over here on this graph, I'm going to say, well, at 0, the derivative was going to go from positive to negative, right? From positive to negative at x equals 0. Positive to negative, okay? And then at x equals pi, it's going to go from negative to positive. There's negative to positive. And then at x equals 2 pi, positive to negative again. And just to check, if cosine's the function, okay, right here, cosine is concave down, so the derivative would be decreasing. That derivative is decreasing. Here, cosine is concave up between pi and 3 pi over 2. I'm sorry, pi over 2 and 3 pi over 2. Pi over 2 to 3 pi over 2. Cosine's concave up. I'm sorry. Cosine's concave up right here between pi. So the derivative would be increasing. The derivative is increasing between pi over 2 and 3 pi over 2. And cosine's concave down here, and the derivative is decreasing. Okay? So this would be the derivative. This green graph would be the derivative of cosine. Well, what does it look like? Well, it looks a lot like sine, but the opposite of sine. It's the sine function, but opposite. So I would say we can probably go to the bank and conclude that the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x is equal to negative sine of x. Similarly, if we were to compute this limit down here, which we're not going to do algebraically, but we'll go ahead and write it out. If we were to compute this limit algebraically, we would get, not that, we would get negative sine of x. Okay? So we have kind of arrived at a pretty significant result here, people. That the derivative of sine of x is cosine of x, and the derivative of cosine of x is negative sine of x. Now that adds, a whole bunch of stuff that we can take derivatives of. Because now that we have these two functions, we can take products of these, quotients of these. We can do these combined with polynomials. In fact, we can also take the derivatives of the other four trig functions. Secant, tangent, cosecant, cotangent. Because those are just products and quotients of these guys. So that's what we're going to do right now after we erase the board. Okay, so here we are. We got tangent of x here. And we're going to find the derivative of tangent of x. Now, tangent of x written like that doesn't really help us, but we can think of tangent, of course, as sine of x divided by cosine of x. Everybody knows that. If you've ever learned about tangent, that's one of the first things that you learn about tangent after you learn SOHCAHTOA, is that tangent is sine over cosine. Okay, so now we're going to take the derivative of this. And how are we going to do it? Hopefully you're mumbling to yourself, the quotient rule. Yeah, that's exactly right. So we're going to say the quotient rule. We're going to take the derivative of this using the quotient rule. So we're going to say low. D high. What's the derivative of sine of x? Cosine of x. Minus high. D low. What's the derivative of cosine of x? Negative sine of x. All over low squared. Okay? And that's, we could be done here, but this actually simplifies and cleans up beautifully because I smell cosine squared x here plus sine squared x. Did you guys smell that? Cosine squared plus sine squared is 1. So 1 over cosine squared of x. Some textbooks actually will just leave the derivative of tangent as 1 over cosine squared. I think it's also safe for us to know that 1 over cosine squared is secant squared. Okay? So the derivative of tangent of x is secant squared. Now I want you to stop and think for a second, okay? Before we do anything else, I want you to make some connections. I want everybody, if you could, dig deep and think about what the graph of the tangent function looks like. If you remember the graph of the tangent function, maybe you remember it looks something like this. Right? That's not a very great drawing, but you get the idea. Okay? It looks something like this. This tangent function is always increasing, right? Which would mean his derivative is always positive. Secant squared is always going to be positive because you're squaring something. Kind of a nice connection. Okay? All right, let's do the cotangent. Let's do the cotangent. What if I said the cotangent of x? Okay? Now there are a few ways that you could do the cotangent of x. You could do the cotangent of x, and you could write it as 1 over the tangent. You could also write cotangent as cosine over sine. Let's do that. Okay, so how are we going to take the derivative of this? Quotient rule. So we say that's low. D high. What's the derivative of cosine? Negative sine. Minus high. D low. What's the derivative of sine? Cosine. All over low squared. You guys smell it? I smell it. I think it's coming. I got negative sine squared of x minus cosine squared of x all over sine squared of x. And if I factor out a negative 1 there, I'm going to get sine squared of x plus cosine squared of x all over sine squared of x. And sine squared plus cosine squared is 1. So this is negative 1 over sine squared, which is negative cosecant squared. Okay? And if you think about the graph of the cotangent, it's always decreasing. And guess what? The derivative would always be negative, no matter what. Because this is positive, and then you always have that negative there next to it. So now I have the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. Okay? I'm going to erase the board, and we're going to come up with the other two. Okay, so we're back. Nice clean board here. F of x is secant of x. So how are we going to take the derivative of secant of x? What are we going to do? Well, we're going to rewrite that. How can we rewrite secant of x? Well, hopefully, I mean, you know this. You learned secant to be 1 over the cosine. Okay, so we're going to take the derivative of 1 divided by cosine. Okay? We're going to treat this like a quotient. All right, so let's do it. We're getting a workout in the quotient rule today. So we're going to say the derivative of 1 divided by cosine is low. D high. What's the derivative of 1? What's the derivative of 1, friends? 0. Minus high. D low. The derivative of cosine is negative sine. All over low squared. So there we go. Now, we're going to clean this up just a little bit. It doesn't require massive algebra pants. Maybe a little algebra knickers. Some algebra joggers, maybe. So Negative times negative, that's 0. Negative times negative is positive, so this is going to be sine of x over cosine squared. Okay? Some folks will leave the derivative of secant like that, and that's perfectly acceptable. But it's also perfectly acceptable to think of sine over cosine squared as sine of x over cosine of x times 1 over cosine of x, which is the same thing as secant of x times tangent of x. Actually, it's tangent times secant, but then I reversed it. Okay? This is just how I've memorized it, secant tangent. You can remember it like this, but just know they're equivalent, okay? So the derivative of the secant function is secant of x times tangent of x. All right, let's do one more, because we only have one left, I think. There's 6 trig functions. What if I gave us the mitter? What if I gave us the cosecant of x and said, let's find the derivative of that? Okay. The first thing we're going to do is we're going to write cosecant like 1 over sine. And then we're going to say, okay, quotient rule, low, d high. In fact, why don't you guys pause the video right now and see if you can work this out on your own and then check it when I'm done. So pause the video right now and see if you get the same answer that I get after you're done. And simplify your answer too. Make it like something like this over here. Okay, so pause, and then I'm going to wait 1 second, and then I'm going to start going. Okay, unpause. Low, d high, minus high, d low. The derivative of sine, cosine, over low squared. So now, again, some cleanup. Sine times 0, 0, minus 1 times cosine is negative cosine over sine squared. So we could be done here, but if we want to make it look like the other one, maybe you did when you did it on your own, you did negative cosine of x over sine of x times 1 over sine of x, and then you end up getting negative cosecant of x cotangent of x. Okay? So the derivative of the cosecant function is negative cosecant of x times cotangent of x. All right? So I'm going to summarize these and write them all down for us in one list real quick. I probably should have paused that so I could erase that, because that's 10 seconds of your life that you're not going to have back. Okay, ready? So here we go. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative, okay, remember I'm using this notation here. When I write d over dx, that's a command. It's like, you shall take the derivative of sine of x. And the answer is cosine of x. Okay? You always will have something. When you have that, you'll always have something next to it. It might just be a y, but you'll always have something next to it. It's like, if you have that, you're always going to have something inside it. Otherwise, it don't make no sense. The derivative of sorry, I didn't want to do cotangent first. The derivative of tangent of x is secant squared over here. The derivative of secant of x is secant of x tangent of x. The derivative of cosecant x is negative cosecant x cotangent x, and the derivative of cotangent of x is negative cosecant squared of x. Okay, so there's the 6 trig functions and their derivatives. You got to memorize these. You got to own them. You got to know them, love them. Okay, here's some helps on how to memorize them. The derivatives of all of the co-functions: cosine, cosecant, cotangent. The derivatives of all the co-functions, negative. They're all negative. Okay, the derivative of tangent is secant squared. The derivative of cotangent is cosecant squared. The derivative of secant is secant tangent. The derivative of cosecant is negative cosecant cotangent. Okay, hopefully you see those patterns there. So now we've got these 6 trig functions. We've got all kinds of functions that we can take the derivative of. So I'm going to erase this board, and I'm going to do a couple of examples where we combine the trig functions and maybe some polynomials, just so you can get a flavor for that. Okay, so we got a nice clean board here. I'm going to grab a sip. Here we go. So let's just do some examples of some functions. How about this guy? G of x is, let's just start off with something nice and simple. 3x cubed times cosine of x. Okay? We're going to find the derivative of that function. Okay? Guys, this is, some of you might be able to figure, get these derivatives, tricks and shortcuts. Some of you might be able to master this pretty quick. You only have to do a few problems and you got it. Some of you might have to do dozens. It's all going to be different. But this environment lends itself to you kind of practicing on your own and figuring out what you need to do. And I'll give you some practice problems here in the book here in a minute that you can do. And if you need more than that, do ones that I didn't assign you. I'll also have you with the Delta Math assignment too. Okay, so here we go. Sometimes it helps if we underline the two things being productized here, 3x squared or 3x cubed and cosine of x. So now we didn't do the product rule. When I do the product rule, I say it out loud every single time. So I say the derivative of the first, which is going to be 9x squared, times the second, cosine of x, plus the derivative of the second, negative sine of x, times the first. And we're done, people. We're done. I mean, you could make that a minus sign. You could factor out a 3x squared if you wanted to, but you don't have to. I want to see that you can execute the product rule there with precision. Derivative of the first times the second, plus the derivative of the second times the first. That's what I want to see. Okay? Let's do another one. How about h of x equals how about, say, tangent of x over radical x? Okay? Now, hopefully you're thinking to yourself, I think I want to write that radical x is x to the 1/2 because it helps me do the power rule. Oh, Mitter, you stupid moron. Guys, I wrote h prime here. That's not h prime, that's h. We're going to find h prime. I was calling myself a stupid moron, not you. So I'm going to, like I said, we're going to write that as tangent of x over x to the 1/2 just to help us. Okay? So how are we going to do this? We're going to do the quotient rule. So that's low, d high. What's the derivative of tangent of x? Flip back to your notes. Secant squared minus high, d low. Now what's the derivative of x to the 1/2? You may have it memorized already because you've done it enough times. If not, you will. All over low squared. Okay? Now, can we simplify this? I mean, I think we can clean it up just a tad bit. We wouldn't have to necessarily, but this is not horrible. I'm just going to make it look prettier. because x to the 1/2 squared is just x. Okay? Do I have to clean it up more than that? No. Could I? Yes. But I'm not going to. Okay? Because again, I want to see that you execute the quotient rule correctly. I don't care if you can do all this crazy algebra. Let's do another one. I could probably fit it right here. I'm going to draw a little line here just to give myself some separation. Wow, some teachers are out in the hall being quite obnoxious. Those teachers. We can be quite obnoxious. Here we go. Ready? How about this? This is one of my favorites. Sine squared of x. Find me the derivative of that baby. Okay? Now you might be tempted. You might be tempted to think of sine of x like this. And that is true. Okay? And then you might want to try to use some sort of power rule, but we don't know how to do that yet. We will learn soon. So why don't we just think of sine squared like this? Sine of x times sine of x. Can we do that? Ain't no thing. Okay. So here we go. How do we take the derivative of sine of x times sine of x? Product rule. So we say the derivative of the first, cosine of x, times the second, sine of x, plus the derivative of the second. What's the derivative of sine? Cosine of x times the first, sine of x. So I have cosine of x times sine of x plus cosine of x plus times sine of x, which is 2 sine of x cosine of x. Ah, okay. Sounds good to me. There's our derivative of sine of x. I'm sorry, of sine squared of x. How about this? How about the derivative of 1 plus tangent squared? That is equal to secant squared, isn't it? So should we just go ahead and call it secant squared? Yeah, why not? If you remember your trig identity, 1 plus tangent squared is secant squared. So this is secant of x times secant of x. All right. I hope we don't run out of room here. So we're going to use the product rule again to find this derivative. The derivative of the first. The derivative of secant is secant of x tangent of x times the second, secant of x, plus the derivative of the second. The derivative of secant of x is secant of x tangent of x times the first, secant of x. Did I fit it all on there? My eyes aren't good enough to see my screen that far away, but I think I did. So that's going to be 2 secant squared of x times tangent of x. Okay? So now you can kind of see a mixture of trig functions and polynomials and things like that. I'll do one more with you. Let me pause so you don't have to watch me. Okay, so we're going to do one more. We're going to find the derivative of this, and then maybe we're going to use the derivative to find the slope at a point or something. So let's go ahead and let's just do it. Say find the equation of the tangent line. Let's pick a nice easy point. What's an x value? That'd probably be really easy to compute p of 0. I just told you. X equals 0. That's an easy one to compute. Okay. So find the equation of the tangent line at x equals 0. So in order to find the equation of a tangent line, in order to find the equation of any line, we need a point and a slope. Let me pause this because Mr. Alexander is going to talk. Okay, so we're back. Mr. Alexander decided all of a sudden that he wants to make announcements to the teachers at 7:55 in the morning. Okay, sounds good to me. So in order to find the equation of a line, a tangent line or any line for that matter, you need a point and a slope, right? So the point is going to be 0, p of 0, And p of 0 is actually pretty easy to compute. Sine of 0 is 0, so that's going to be 1. Okay. Now we got to find the slope. In order to find the slope, we're going to find the derivative. So here we go. And in order to find this derivative, we're going to use quotient rule. Okay. So here we go. Low. D high. Now I'm looking at the derivative of the numerator. The derivative of 1 is 0. The derivative of sine of x is cosine of x. Minus high. D low. Okay, so the derivative of 1 is 0. The derivative of negative sine of x is negative cosine of x. All over low squared. And don't forget these parentheses here, friends. Okay, those parentheses around the bottom are kind of important to get out of the way so you don't have to look at my head and the math at the same time, because that would be horrible. So now let's clean this up. Okay? We have to find p prime of 0, and it's probably going to be a little bit easier if we clean it up first. So this looks like 1 minus sine of x times cosine of x. Minus minus would be plus 1 plus sine of x times cosine of x over 1 minus sine squared of x. Whoops, midder. Got a little carried away there. 1 minus, oh, got a naked sign here. 1 minus sine of x squared. There we go. Now, I suppose that we could go ahead and evaluate this at 0. If you wanted to clean it up more, you could distribute the cosine and then clean from there. But I think we could probably just go ahead and evaluate this at 0, because sine and cosine at 0 are pretty easy to work with. So p prime of 0 is going to equal 1 minus 0 times cosine of 0. Now what's the cosine of 0? 1 plus 1 plus sine of 0 is 0. Now what's the cosine of 0? 1 over, running out of ink here, friends. I must use pink more than anything. 1 minus sine of 0, so sine of 0 is 0, so that's just going to be 1 minus 0 squared. Looks to me like that's 1, 1, so that's 2. And this is 1, so the slope is 2. So now I'm going to go over here and say the equation of this tangent line, ready, is y equals 1 plus 2 times x minus 0. Okay? So I found the derivative using the quotient rule, and then I just used that derivative to get the slope, and then I used the point from the function and did my tangent line equation. So now we know the derivatives of all 6 trig functions. We know how to find combinations of those and combinations of the trig functions and some polynomials or radicals. So we have quite a repertoire. So I'm going to give you some problems out of the book to practice this with today, and have fun.